Hi everyone, my name is Vinicius Santana. I'm a PhD candidate in chemical engineering at the University of Porto in Portugal, and today I'll be presenting our simulator entitled Hybrid Nonlinear Advection-Diffusion-Sorption Simulator. I'd like to thank my advisors, Delfonso Nogueira, Ana Mafalda Ribeiro, and Christopher Calcas, and also the other two co-authors of this work, Carini and Herbert. So let's get started by showing what advection-diffusion-sorption model is. It's basically a partial differential equation that aims to describe the transport of a solute or a chemical in a fluid media where advection, diffusion, and sorption are relevant phenomena. So here I brought this time-dependent one-dimensional version of this equation, and the fact is that this equation finds very important applications in chemical engineering, for instance in describing the separations in column chromatography or even in reaction engineering. So I brought a illustration of what would be an equipment where this equation is important. In chemical engineering we call this fixed bed. It's basically a pipe, and inside this pipe we have a solid material, usually spheres, that can play the role of a catalyst or an adsorbent, for instance. And the fluid is allowed to flow in the empty space between the cylinder and the solid material, right? And at the interface between the fluid and the solid, a relevant phenomena can occur. For instance, it can be a separation or it can be a reaction. So in the context of those equations, there is one particular term that plays a very important role in the solution of the equation, which is the sorption term, right? The sorption term can take several forms. For instance, it can be what we call a linear driving force, or it can be nonlinear, for instance, just the subtraction from these two quantities squared, and it can get very complicated, right? So it's very important because depending on the functional form you choose, the solution to the differential equation changes a lot, and it impacts the predictive power of the model. And if you use this model to design an equipment, then you expect the design to be very different, right? So how do we pick the correct functional form a priori? So instead of trying to guess beforehand what's the functional form, we can just replace this function by a neural network, which is a universal approximator, in the sense it can approximate any continuous function, even high dimension, 2D, 3D, right? And we call this a hybrid model for the fact that we are mixing a conservation equation with a data-driven model inside of it. So here's how the model looks mathematically. So I brought an image of how the model looks in a programming language. So we implemented this hybrid model inside of Julia, specifically under the ICML ecosystem, because we have very nice functionalities for implementing neural networks inside of differential equations in it. So you can check the full code at this GitHub repository. Let me just give you a second to take a print screen or a picture of it. So I said that we put a neural network inside of a differential equation, but we have to find the parameters of this neural network, right? Which means calibrating our model. And we do so by formulating an optimization problem where we try to minimize some cost function which is proportional to the difference between my prediction and my observations. So here I brought an animation to show how the training process or the calibration of the neural network happens inside of this hybrid model. Here you can see the blue circles being the training set, and we can see that as the training process evolves, the predictions get better and better at predicting the training set data. Not only the training set, but also the test set data we set up to validate our model. Also, this training process can be carried out using the code available at the GitHub repository I've shown you before. So what's next? You may use the identified piece of the model, the sorption term or uptake rate term, in another application. For instance, you just grab the neural network and using a batch chromatographic unit or using a chromatographic reactor model. Or you can use the hybrid model itself to optimize your unit or even control it. I'd like to acknowledge all institutions involved in this work, FCT, MIT, Portugal, and I'd like to thank you for your attention too. Bye.